Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, perfect squares. So let us first read this question and then about the constraint and then the examples which are given to us and then about the intuition and finally the coding and time complexity and space complexity. So here, given an integer n, return the least number of perfect squares that sum to n. Perfect square is an integer that is square of an integer. In other words, it is product of some integer with itself. For example, 1, 4, 9, 16 are perfect square of while 3 and 11 are not. So basically whatever n is given to us, we are required to return least number of perfect square numbers that sum up to this n number. And constraints which are given to us that n could be 10 raised to power 4. So in that context, n square solution could easily work or n log n. N square solution 10 raised to power 8. Most probably it not work n square solution. So n log n solution would be required or n solution. So now let us check that how we are required to do this question. So we are required to figure out least count of perfect square till n. So in the first example, 12 was given to us. We are required to figure out the least, uh, basically count should be the least and all the count of, and that count includes the count of all the perfect squares which are there and that sum up to this n which is given to us. So 4 and 9 that equals to 13. So we can't take this. Then 4 3 times if we take then it becomes 12, right? And all of them are perfect square. Then 1 plus 4 and up till this it also add up and give us 12. But it is having the count which is greater than this count, right? And then we can also go ahead with 1 because 1 is also a perfect square and we can write that 12 times. So its count again becomes greater than 3, right? So that's why our answer is here 3. And that is what it is being given in this first example as well. Now, if we go ahead by just taking total number of perfect squares. So basically, if the way here I've done 4 plus 9 or 1 this much times and 4 this time so that we can get our 12 as answer. If we do simply just like this and then add and then check, then it won't work because here we can see from this example that it can't work in that manner. That's why we are required to modify this particular solution. Means we are required to check for these perfect squares, but that we are required to check in that manner so that we could minimize the count of all the perfect squares which are there, which can add up to 12. So we need to figure out all possible combinations and check minimum count of perfect squares that add up to n. So basically, intuition behind this particular question is okay. We need to check for possibility that can try with recursive approach to find all possibility or iterative way. For proceeding with iterative manner, best we would be going ahead with iterative DP. So algorithm for the same would be because we are going ahead now with the iterative DP. So first we require a base case and our base case would be directly when n is basically less than or equal to 0 because when n is less than n is negative then we can't add up any of the perfect square to get that n, or if it is 0 then also nothing would work because 0 is not a perfect square. That's why we are required to return 0 at that moment. At the starting, we will be initializing answer vector with int max because we are required and this answer would be having a count at every point of time. So that's why and we require to minimize the count. That's why we are initializing with int max and the size we will be taking as n plus 1. Why n plus 1? Because answer of 0, we want to put that as 0 only. So that is the scenario here. Now our state of this DP would be answer of 5. Basically one variable state would be there. And now transition, how it takes place. So for I, in the range of 1 to n. Means we will be uh, going from 1 to n, and then inside that we will be going ahead our j from 1 to I. And here we are required to keep a check that when we do square of that j, then it should be less than or equal to I. And why we are doing that? So that we can do our counting like this. Basically, at every moment of time, we are required to check that what is the minimum possibility that if our present count is minimum, or if when we subtract our this particular perfect square which we have just formed from the I, then at that point of time, whatever count was there, and when we add one to the same, if that is the minimum, then we will be adding that count to this answer of I. Else answer of I, whatever is there that is in max at that moment, that would be there. So at the end, we are required to return whatever we have stored at the end of our answer. So now comes the part for the coding of this particular question. So here, this is the base case, and then here comes the part initializing our answer vector with int max, and its total count would be n plus 1, means basically the size. And then at the starting, we are initializing the zeroth, means basically at the zeroth index, we are putting at 0, because when we are having n as 0, so we are required to return 0 itself. So that's the case here. Here why we have put this, so that at the starting only, okay, this thing we can eradicate even. If I we eradicate, then it should work, because we are handling that base case at this point only. So that's it. And here then if we go ahead for int I equals, yeah, that works, so we can eradicate that case. Actually, it was for the base case only. So that base case we are already handling here. Means at the zeroth index, we will be storing the 0. And then we are starting from when it going till n, and even here we are taking this j, which will be calculating perfect square, and it will be checking that each perfect square should be less than our present I, which is there, so that we can easily do this particular operation. And then here we will be checking that whatever is minimum out of them, that would be stored at that index, and at the end we are going to return whatever last was being stored in this particular vector. So now comes the part first, time complexity. So here we can say that here the time complexity is basically order of n for this particular loop, and here the time complexity, it is going from 1 and going till I. So in the worst case scenario, when I becomes equals to n, means when it is at the last, then one would be this j would be going till n, right? So in that particular scenario, here it becomes n. So that's why the time complexity here becomes n square, and the space complexity here, that is order of 1 only, because we are not using any auxiliary space. So this was all for this particular question. Thank you.